Hello, thank you for taking time out to view our presentation on the Health Alert wristband. My name is Constance, and I'm partnering with Janel. My background coming into this was healthcare and hospitality. My healthcare experience was as a liaison for healthcare and hospice between doctors and nurses at Presbyterian Hospital here in Albuquerque. I, during that time, wanted to go to nursing school, so I got a pre-health associate's degree, and I was trained as an EMT so I could work in the emergency rooms. That didn't quite work out, so I ended up at Nexus Restaurants as a corporate leader that I just left, and that's my background coming in. I wanted a change of pace given the COVID pandemic, and I gave this class a try, and I'm loving it, and I'm hoping to pursue it further.
And good morning, I am Janel Sanchez. I also come from a medical background. I'm a certified pharmacy technician over the past 13 years, with my most recent experience in community emergency and mental health medicine. Last year, I really craved some more public interaction and integration. So I took that leap and started with Deep Dive. I actually completed the digital media boot camp last summer. I'm searching for a career change right now, just wanting to further my education so that I can give back more to my community. I also have extensive volunteer experience, and I've worked in the hospitality, retail, and customer service industries for about over 18 years.
So we want to go ahead and give you an overview of our product. What we've designed is a health alert wristband. We came into this with big dreams. We had wanted to monitor medications in the system and inject medication according to need. And so according to our skills and our available sensors, we had to scale it back with the help of our instructors. And we came up with this health alert wristband. What it does, what our prototype has, is the ability to gauge temperature, oxygen, heart rate. We have a fall button, a fall alert sensor, a call button, and the ability to set medication reminders. The benefit of this health alert wristband is that it's wireless, it's convenient, and patients in the hospital setting or a home care setting can be continuously monitored. By being able to do that, it gives the patients or resident the independence, it gives them privacy, and it gives the family peace of mind because all of this information is fed to the internet, up to the cloud, depending on who is going to be receiving it. They can see the data, temperature, heart rate.
All right, so bear with us. Let's see if we can get this video playing for everybody. We hope you enjoy. This is going to be a video of a demonstration of our Capstone project, and we're going to invite questions and comments at the end of our presentation.
I'm going to orient you to the layout of our Healthcare Alert wristband. These are the two sensors we're using to collect 3 different vital signs. The display, the sensor for falls, the alert button, the particle argon, the breadboard used to wire all the components, the clear encasement created to demo our device, the 3.3 volt battery used to have wireless communication, and the adjustable wristband.
In our device, to assess what we determined to be important vital measurements, we integrated 2 I2C sensors, the MAX 3102 and the BMP BME 280. The MAX 3102 is a high sensitivity pulse oximeter and heart rate sensor, while the BMP BME280 measures temperature, pressure, and humidity, which we only use temperature for our device. Both have been placed at the bottom of the device closest to the palm so that when the device is on, they will sit snug against the palmar surface. When the measurements are taken, it will display those measurements to the incorporated OLED display for the wearer to see, as well as utilize a MQTT broker via the cloud to publish the data to the Adafruit.io system. As our device measurements are being taken, this data will continuously update on the OLED display, along with publishing to Adafruit. Here we have created a dashboard in which the wearer or other party could monitor the vitals being recorded online. We wanted to provide a way for the device wearer to have manual emergency communication. For example, if they fell and needed to alert someone. We incorporated a button along with the Adafruit.io system and Zapier, an online automation tool to do this. At any point, should the wearer need assistance, with the press of a button, a value determined in our code will publish to Adafruit, where Zapier moves the information received and triggers a cell phone short message service. So, if you had fallen and needed assistance, pressing this button would allow you to notify someone via a text message. Other applications could be used in place of the SMS, as this was the one we chose for demonstration purposes. Another way we incorporated the fall scenario was including an additional I2C sensor, the MPU 6050, a 3-axis accelerometer and gyroscope module. By taking the total acceleration from the X, Y, and Z axes, using the accelerometer, we can determine a value in which we then associate to a potential fall. Should this value be detected, we publish the data to Adafruit and employ Zapier to trigger another SMS message to the cell phone number we chose. So, should someone have a potential fall, which we demonstrated with that brisk movement of the arm, then we are again able to notify someone via text message. With Zapier, we were also able to demonstrate how you could use this application to create daily reminders. We generated 2 daily reminders that send a text message to the cell phone at the designated times we requested, 10 a.m. and 9 p.m., which will remind someone to take their medication.
So as we designed this and put it together, we took individual sensors and tested them individually to make sure that they worked. We coded them and then we blended them. So we started off with the BME, which is an environmental sensor, and we used this particular one in our temperature. The MPU 6050 is something that we used in class to test shock and acceleration. We translated that to a fall and incorporated it that way. As we coded and blended, we worked as individuals and then put it up together. We worked on Hackster as we went and uploaded that. We have a site for you to view at the end of this if you'd like to visit that. Troubleshooting for me particularly was learning to take sensors we had worked with and translate that to a healthcare need. So that was interesting for me to sort out and to work with the classmate and blend code. So that was my troubleshooting and my challenges.
One exciting and challenging aspect of our project was locating a new component that we could measure one, if not more, of the critical vitals that we wanted to work with. So we found the SMAX 3102, which is a reflective transmitter sensor. It uses LEDs to detect changes in light being passed through the blood. And in doing so, it's able to take these readings by filtering out the noise and signals to provide accurate values. When it came to our design, from the beginning, we had always envisioned a wearable device so that it would be mobile for the user. Learning so many new design techniques, being able to design a custom enclosure seemed to be our best bet. Unfortunately, after the 3D model that we designed using Fusion 360 was complete, it became apparent that it would not really be as compact as we had envisioned. So Plan B came into effect, and we went ahead with a whole nother program using Corel Draw, designing a new box template and utilize the laser cutter, which you see here in this video, that's provided at the Fuse Makerspace to complete our box design. Again, when it came to coding, we learned a ton, and I mean a ton, lots of research to especially the new component, how we could use it and integrate open source code to find the values needed from the sensor. We also really took advantage of that MQTT, allowing us to communicate for broker purposes, offering us that flexibility and peace of mind for consumers. And again, with that, Adafruit and Zapier, those are awesome. They're such wonderful features, being able to provide us that extra step of communication. So for us, it really came down to determining which values were most important to publish online and which ones we needed to use for communication for that separate device. And as far as troubleshooting for myself, really understanding how that MAX 3102 component works, learning that in the world of coding, there are so many examples out there, open source stuff. And so being able to learn which pieces out of which parts of code and understanding what those pieces of code actually mean to being able to get it to work for your project was really one of my bigger challenges for this guy, especially because there's a lot of math behind it. Something that we also look forward to building on is getting our complete product, our component and code to work together consistently. What we were having trouble with towards the end of our project was that sometimes certain features, like using that MQTT for communication, seem to prevent our device from working properly. And because this is a medical device, that's definitely something that we want to overcome. Did you know that the impact breathing can have on your mind and body? Not only can it lower your heart rate, it helps decrease blood pressure and aids to lower stress levels. So right now, we're going to do a little interactive session with you guys. We invite you all now to do a little 10-second breathing exercise. So if everybody could just sit back, and I ask you to take a deep breath in, counting to 5. 1, 2, 3, 4, 5, and let it out. 1, 2, 3, 4, 5.
So in the future, other aspects that we would like to see this morph into would be preventative care. When somebody has a diagnosis that they need to monitor more closely, they can start off by wearing this device and keeping an eye on it for themselves, and then uploading it to the doctors, nurses as needed. For an individual use, it could also be used for stress management, just to keep ourselves calm, like the previous breathing exercise. For EMS purposes, this could be used by survivalists. When they pack their gear, they can take this with them. If they bump into any issues along the way, they can upload it and be monitored before EMS reaches them. So that's another aspect that it could be used. Again, if they run into problems and they don't have this device, it can be sent to them by pet or dropped helicopter. There's different versions. I'm not an expert on that, but it could be dropped to the person and utilized to get vitals to EMS before they even reach the person.
All right, that wraps up our presentation. Again, we greatly appreciate you guys all taking the time out of your busy days to join us. We know this has been a crazy 10-week journey, but it's been nothing short of simply amazing. So we'd now like to open it up for any questions or comments.